So this is a topic we're going to spend a lot of time with when we get to polynomial functions next. But I'm going to introduce it with quadratic functions. And we're just looking at for which values of its domain are the following functions increasing and decreasing. And this is in your notes. First of all, some important things. Number one, we read graphs left to right. All right, so from negative infinity to positive infinity. And I'll even put x equals negative infinity to x equals positive infinity. You can't start somewhere in the middle of the graph. Right? And what we're looking for is where's the graph increasing and where's the graph decreasing. Now imagine these are roller coasters, right? So you're on a roller coaster ride. And the roller coaster goes up, the roller coaster goes down. What's the exciting part? Well, of course, it's when the roller coaster goes down. Right? So I'm not a very good drawer here, so pretend that's the little roller coaster cart. Right? So if the roller coaster is going down the hill, the exciting part, that is decreasing. And actually, I'm going to write that in green. I'll put green for decreasing. Because if this were really a roller coaster, that's the part where you go really fast. Right? And we might have, sometimes the roller coaster goes up the hill. Here's a roller coaster going up the hill. So if the roller coaster is going up the hill, the graph is increasing. And one thing that makes it nice and easy for quadratics is it's increasing for half the graph, it's decreasing for half the graph, and it turns around at the vertex, right? So we're going to switch from increasing to decreasing or decreasing to increasing always at the vertex, right? For quadratics. Now that's not going to work for when we get to polynomials because they don't necessarily have a vertex. But for our quadratics, we're going to change at the vertex. All right, so let's look at the first graph. All right, so we read graphs left to right. All right, so this is the farthest left where the graph is drawn anyway. All right, we know it's going to keep going to infinity, but someplace the person had to stop drawing the graph. All right, they're going to run out of space. All right, so we're going left to right. So when we start off, we're going downhill. Here's a roller coaster going fast, 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 fast. And then we get to here, right? And now we're not going down anymore. So right here, our graph is decreasing. So label your graph. And I suggest color coding it. All right, when you get to the vertex, you turn around, and now the roller coaster is going up, 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 up. The roller coaster is increasing, and the graph is increasing. So now for the graph, let's write down where it's decreasing and increasing. All right, so this is graph, we'll call this one graph number 1, because it was first. So graph number 1, and I'll put 1 over here, because this is for all the graphs, that part. But for graph number 1, our graph is decreasing. And for all of them, I'll just start with decreasing. The graph is decreasing from negative infinity, and remember, it's the x. So when we're looking at which values, it's always domain, and domain is x. All right? If we're looking at range, and we're only going to be looking at range if we're looking, if we're identifying the range, or the lowest value or the highest value. Then we're looking at y, but we're looking at the x. So negative infinity, the vertex is at, I'll put that in another color so don't confuse that with increasing and decreasing. The vertex is at 4, what is that? 4, 4? I think it's, or excuse me, 4, negative 4. So the graph is decreasing from negative infinity to 4, right? It's where, it's the x value. And the graph is increasing. So right at 4, it changes, and it's going to be increasing from 4 to infinity. We use a parentheses, not a bracket. Yes, 4 is part of the domain, but who's to say when at 4 it's increasing and when it's decreasing, right? It's right at 4 it switches, so 4 is really not included anywhere, right? That's the place where it switches. And we have identified decreasing and increasing for the first graph. Let's do the same thing for the second graph. All right, again, we read left to right. Here's our leftmost spot that has been graphed, because there's only so much room on this graph. And what do we do when we start off? Why, we're going downhill. Yay, this is the fun part, right, of the roller coaster. So the graph is decreasing here. Oops, I was trying to write sideways. It's not that easy. There we go. And then at the vertex, so the vertex is located at -2, -3. At the vertex, it switches to increasing. All right, so we want to identify, this is graph number 2. For graph number 2, where's the graph increasing and where's the graph decreasing? We'll start with decreasing. I could have started with increasing, but it doesn't matter. Decreasing from, so we start off right in the beginning, we're decreasing, so it's -infinity. We switch at the vertex, and it's where, so it's when, not what, so the when we switch is the x value. It's the domain, right? So -2 is when we switch from decreasing to increasing. Right? So increasing, the graph is increasing from -2 to infinity. It's never going to stop increasing now. Let's do the last one. All right, and I'll write it there. So this time, so we're going to go all the way to the left, right? This time we're increasing first, right? The y values. And by the way, how can you, so I think of it as a roller coaster going down, the roller coaster going up. But the other way you can think of it is, are the y values getting smaller or larger? Right? So here the y values, they're getting larger. This graph is increasing. So if your y values are getting larger, the graph is increasing. When the y values are getting smaller, the graph is decreasing. But really, you can just look at the graph. Is it going up? Is it going down? Just make sure you read it from left to right. And where does it switch? Why, it switches right at the vertex, and that vertex is at 0, 0. So let's just be consistent and do decreasing first. The graph is decreasing. It starts to decrease at 0, and forever and ever it's going to decrease after that. But the graph started off increasing. So it increases from -infinity to 0. Right? So here you get a little look at increasing and decreasing. We're going to spend a lot more time with it when we get to polynomials. Quadratics, they only switch from increasing to decreasing once. Polynomials can switch increasing and decreasing several times. Right? But is your graph going down as you look at it from left to right? Or that's decreasing. Or the y value is getting smaller, that's decreasing. Is your graph going up as you look at it left to right? Or are the y values getting larger? That's increasing. And that's all there is to where's your graph increasing and decreasing. All right, thanks for watching. Bye for now.